Hi everyone. So in this video session, I'm just going to solve a question from analog communication. Okay. So my idea here is to show you, if you don't know, let's say you forgot everything in analog communication, but still you can solve this question if you know how to compute power, okay, of any sinusoidal signal, okay, or cosinusoidal signal. So this question was asked for 2 mark. Okay, so let us have a look to this question. So this kind of question has already been asked in the gate previous year. Okay, so if somebody has done, okay, carefully all the PYQs, okay, so they will be able to solve this kind of question, right? So in 2025 also the pattern is gonna get repeated. That is what my emphasis always is going to be. So I request everyone to solve all the PYQs which are given in gate electronics and communication, right? So you see this question was asked for 2 mark. So and this is for 2 mark. Okay, remember this is important for everybody. So an amplitude modulator has the output. So this is a amplitude modulated signal. Okay, ST is given, which is A cosine 400 pi t plus B cosine 360 pi t plus B cosine 440 pi t. Okay, so here you have to identify the terms. Okay, please remember that you have to identify the terms, which one is a carrier term and which one is the side band terms, right? So you can see here this is going to be your carrier term. Okay, you can see here the omega c is 400 pi, and these are nothing but omega c minus omega f. You can say minus omega c minus omega omega m, or omega c plus omega m, right? So these are the two side bands, and this is nothing but a carrier signal. Okay, 1 2 3. So there are three terms given, and this kind of question has already been asked. Okay, and this question also you will find in various reference books like Procis and all, right? So what they have given here is they have given this modulated signal, and they are asking you to compute the value of B here. Okay, the carrier power normalized to 1 ohm resistance. Okay, so they have given 1 ohm resistance here, so you don't have to worry about now the resistance, which is 50 watt, right? So they have given the PC value, which is 50 watt. Okay, now what they have given here is the ratio of total sideband power to total power is 1 by 9. So what is total sideband power? How to compute power from the sinusoidal signal? Let's say let's say you want to find the power from, let's say you have got am cosine omega mt, right? So if someone is going to ask you what is the power out of this, so you can say am square by 2, right? This is going to be the power here, right? Am square by 2. You just find out the RMS value and take the square of the RMS value. That is going to be what? Am square by 2 here, right? Next is you have to just follow whatever is given in the question. That's it. Okay, you don't have to worry about modulation index, all those things. Okay, because that is going to waste your time. So they have given the ratio of total power sideband. What is total sideband power? From this you will get B square by 2. From this you will get B square by 2. So you can say B square by 2 plus B square by 2. That is total sideband power upon. Okay, since they have given you the ratio. The total power is nothing but what? The carrier power plus the total sideband power. So that is nothing but carrier power is nothing but PC, right? Carrier power is nothing but PC. That is, if you try to find carrier power, so A square by 2 is gonna be the carrier power. But you don't have to compute carrier power, okay? Since carrier power is given, so PC plus B square by 2 plus B square by 2, that is total power, which is given as 1 by 9. Now you have to just simplify this, okay, expression. That's it. So we can simplify here. So this is B square by PC plus B square equal to 1 by 9. So just plug here PC, BC square upon 50 plus BC square equal to 1 by 9. And if you're able to do here the cross multiplication, so it will give you 9B square equal to 50 plus B square. Okay, and you can take B square this side, so it becomes 8B square equal to 50. So B square is going to be 50 by 8, right? So you can say this is going to be 25 by 4, right? So you can just find B here. So V is going to be 5 by 2, which is nothing but 2.5. Okay, so the answer for this question is 2.50, you can say, right? Two decimal places means answer for this question is going to be 2.5. Okay, so many of you might do this question like this also. Let me give that approach also. Okay. So this is one way of doing directly. If you know how to compute, let's say that you have got Vp cosine omega t, and what is the power here? What is the RMS value? That is Vp by root 2. And if you want to find the power, that is Vp square by 2. This is the power, right? And since the resistance which is given here is 1 ohm, right? So let's say we have got the question here, okay, and many of you might remember the standard expression that st equal to ac square by sorry uh, yeah, so many of you might remember this kind of formula or standard equation, okay, because ac cosine omega ct plus ac mu by 2 cosine omega c plus omega m, right, times t plus ac mu upon 2 cosine omega c plus omega m times t, right? So this is the standard expression, okay, for uh, amplitude modulation, right? So this is a carrier term, and these are nothing but the sideband term. You can say this is upper sideband, this is lower sideband, upper sideband, this is lower sideband, right? And this is the carrier, term. Okay, we always send carrier. Understand? So many of you might, the moment you see the question, you might do like this also. Take care. लेकिन देखो amount of effort that you're going to put here, okay, by just by finding, since carrier power is given, so you don't have to worry about this AC value and all, right? Okay, just compare this, okay? So I'm just going to compare, right? So here AC is nothing but A, right? And AC mu by 2 is nothing but B, right? So from here you have to just know what is mu here, right? How to find mu? Okay, how to find mu is the question here, right? So how to find mu? Mu is nothing but what? Since they have given this information, and AC you can directly find out, but as I told you, you don't have to worry about AC, right? If you want to find AC, AC is nothing but what? AC square by 2 is given as 50, that is carrier power. AC square by 2 is given as 50, that is carrier power. So AC will be simply 10, right? 15 to 200 means AC is gonna be 10. So ratio of total sideband power. So from here you can see here, this is the total sideband power, right? Okay, I hope this makes sense. So what you have to do here is you just take this square of this square of this, find out the power from here, find out the power from here, and then take the total power, right? So I'm just going to do that. So you will get here as mu square plus 2 mu square equal to 1 by 9. Okay, so this is the result that you're gonna get. So the sideband power upon the total power is known as the efficiency. Okay. In the classroom, these things we have discussed. These are the important parameters. Okay. But if you're going to put all those value, let's say AC square mu square by 4. Okay. I think this is clear, right? Okay. So upon here you will get AC square by 2 plus AC square mu square by 4, right? Which is nothing but 1 by 9. If you're going to simplify this, you will get the same value like this. Okay. Why I have written AC square mu square by 4? You know that since AC mu by 2 cosine something is given. So the power here is going to be, what is the RMS value? That is AC mu by 2 root 2. So AC mu by 8 is going to be the upper sideband power, and the lower sideband power is also going to be the same. So if you add this, so you will get AC square mu square by 4. So these many steps you have to do. And I think nobody is willing to waste this much time if you have attended my classroom, right? So don't do all those things, whatever asked in the question. Okay, directly you should know how to compute power from the sinusoidal signal, right? So, and you should also be able to identify that this sideband power upon total sideband power upon the total power is nothing but a efficiency, that is mu square by 2 plus mu square, as long as the signal is master signal is sinusoidal here, right? Single tone. Okay, so you can find out mu square by 2 plus mu square, which is 1 by 9. So again, you could just cross multiply. So 9 mu square equal to 2 plus mu square. Okay, so you just get here 8 mu square equal to 2. So mu square is going to be 2 by 8. Okay, so from here you can say mu is going to be what? 1 by 2. So AC mu by 2 is going to be what? AC mu by 2. Okay, AC mu by 2 is nothing but this, B. Okay, so AC, you know, that is nothing but 10 into 1 by 2 by 2, which is B. So from here you can just compute 10 by 4, which is 5 by 2, which is 2.5. So you see, amount of hard work, amount of time that we are going to waste in this question is this much. So I believe you guys have understood. So this is the alternate method, I will say. Okay, this kind of method you will find everywhere. Uh, any coaching you refer, any educator you refer, they will tell you this method only. Okay, the standard method. But what I encourage people here is try to save your time for any other question, such as solar cell question. Okay, in GATE 2024, one question was there from solar cell. You can save time for electronic devices question. You can save time for any other subject like analog circuit. Saving time is very important in GATE examination. Okay, for tough questions, which you consider they are the tough question. Okay, so I hope you might have enjoyed this session. We will meet in another session. Thank you.